in the microcontroller code by STM32Cube, and we have here the, as usual, normal includes. I mean, just for to explain from the beginning, you need three three semesters of the university to understand this code. I mean, you can learn it by yourself without being a student or the have any degree, but anyway, if you have a degree, you already know how much time I took to understand and to make this kind of code. This is a simple code and a simple algorithm, as I usually do when I have LEDs and buttons and sometimes sensors. Yeah, I have an endless loop, a while one loop, as everyone knows in the microcontroller community, and I let it pass through a prioritized queue. What is a queue? Queue is a linked list. Yeah. Okay, linked list don't with and with priorities. Yeah, you can swap the pointers just to bring the queue forward or backward. I mean, it's nothing special. I mean, just yeah, of course. And in the while one loop, you have a case inside. So if I press the button in the while one loop, I have a if statement, and this if statement, if the button is pressed, is going to be enqueued, and later on in the same loop, dequeued in the case loop. So I can come in and I can do jump. I can jump inside of the while loop from bottom to the end and so on and so on. So this is the way I program things when I'm outside the real-time operation system, and when I have many things. If it is a simple thing, a simple sensor, you can do it in one loop, is no problem. But if you have many things and you need to also to prioritize without having mutexes. Okay, mutexes and semaphores is for the real-time operation system, but in this case, I have a prioritized queue. This makes a lot of sense if you're not in the real-time operation system programming. Okay, so let's take a look at the code. Not to make this video nor extend this video a lot. So see, I have put here global variables. I mean, I could put these variables elsewhere in the code, but I mean, yeah, uh, it's okay to put them in the as global variables. We're not in the RTOS environment, so the RTOS environment is different because you have to be careful by accessing the global variables inside different tasks. Yeah, so let's go. The struct for the queues, the queue itself, and prioritized queue. The prototypes, the main function. This initialization is done automatically by the SM32 cube. That's why I made this, because you don't need much to read much and to configure that much. This spares you a lot of time doing this. The clock configuration and the oscillators that you have connected to the microcontroller, the crystals. So this is the GPIO initialization and the E square C initialization. I will explain more further how this thing is done. I'm not explaining, I'm just doing an overview. Yeah, because I cannot explain everything because this video would extend like hell, and I don't want this. It's just I want to show only the idea and how the did I program it so it works. And I have to show the program so I can prove what is seen in action is really happening. Yeah, it's really what I said because I have to prove through the programs. I can upload the program also, but I need to have the people needs to ask me to upload the program. This is I can upload the program either. So let's take a look at the while endless loop. It as the if statements in case of the buttons, yeah, of the inputs. Yeah, and I have a main if with a queue, and after the prioritized queue being dequeued, I have a switch loop which allow me to access different programs in different functions. Yeah, in this case, oh yeah, I have to initialize the LED. The bitmap is the monkey riding the dog. This is bits the bits to that bitmap. So and then I have to update the screen. So you have to write to the LED and then right after update, else the LED won't change. So uh, okay, let's go back into the endless loop and then the switch. So I already explained this button. So if you press the button, you're not going to press the button again without allowance from the function that the button is clear to be pressed again. So this is, I think, intuitive for all the programmers. So inside the switch there are different cases being dequeued for the case. And this case is it's the logo, yeah. This is the logo being back. Okay, this is the comeback from everything. This is yeah, the changes in the menu changes. This is the changes in the menu. Yeah. And this year is the okay. This is the thing. The after yeah, okay. This is the queue from the options. So you have different options. You're going to queue what the options, and it's going to be feedback in the loop again. So you can go out of the case and go in again through the queue. I could optimize this, but because I have the statements here are similar, I mean, could put this variables in a function, but I mean, this is only a Boolean, so this is 1, 2, 3, 4, 5 bits. Yeah, I could optimize this, but I mean, making a function for 5 bits, questionable. Anyway, let's move forward to another case. This is the to transmit the PLC, which number I want to access the number the memory from the PLC. I have programmed three choices to grab data from the PLC. Three 16-bit memory, a word, yeah, or a 16-bit integer. It's I don't care how you say. You can see it in different ways. So I have three options, one, two, and three. Yeah, there's three cases here. And in the case loop, I'll read the data. I give the orders to the PLC, and I read from the PLC and put it into the LED. Yeah, and this is all made in the function by pointer. So they all point to this char variable with 16 characters. It's a vector, no? Char vector. How do you, no matter how do you call it. So, and that's it. It's over. It's simple code. Yeah? It's simple. It's a bit complicated if you don't quite understand. I think with 3 semesters you do understand. So, and let's go to the functions so we can go deeper in the code. This is the main menu from the LED, and this is the menu the function in order to read the variable that come from the PLC. Yeah? Let's do it. That's done by pointers. Yeah? Pointer temp, and then it's going to be print. This function is going to return. This is the main function with a monkey, the happy monkey riding the dog. And this is here the function to read, similar to the first video that I write to the PLC. This is writing the option to the PLC. This is writing the option. It's exactly the same kind of code. Yeah, this is the same. In this case, I return true in the function. I have a boolean here, and I return true if everything goes well, and if not, I return error. I return false. And it goes in the error loop because this is an endless while with LED blinking error. So, and this is then shown. The next one is the receive function. Receive. From the microcontroller point of view, we are in the microcontroller point of view. It's kind of confusing here. So, what we have here? This is a while loop that waits that the previous function waits that the previous function add the current okay, well, and the output from the pin output from PLC it's off, then it moves forward. And this is only the LED. The LED doesn't mean nothing, it's only for the bug, but this pin 8 from the microcontroller tells the PLC that the microcontroller is giving the orders to send the impulses in this case. So and this also tells also with 16 bit a for loop with 16 bits. In this case, the pulse orders are going to be done by the pin 9 from the microcontroller, and the pin 10, this is the input from the microcontroller, is going to be read the impulse from the PLC. So if the PLC is the output of PLC is on, it's going to be 1 in the char vector. It's going to be 1. And if not, if there's 0 voltage there in the input, then it's going to be 0. Okay, and the pin 9 is going to be given the tagged on and off. On and off is the PLC putting the output on or not. Yeah, in the first video, the 3.84 volts with the LED and the diodes. If this voltage is made, And then is means there is a 1 in the input. If there's no voltage there, then the output is going to be 0 and is going to be pointed buff to the char vector in the global variable. So, and when everything it's done, the pin 8 of the microcontroller is going to set to the is going to be off. So the microcontroller set to the PLC that it already has the 16 impulses and work is done. So and the loop ends here. The function ends, loop ends. So um, everything else now the next function is the error function, the endless loop with a blinking light, and this is the that I always use in my projects. Yeah, and this is some sort of copy paste that I do for myself. I'm copying myself. Yeah, it's a prioritized queue with linked lists and with a priority. I mean, you can set the priority up and down as you want. I mean, it's a bit complicated because it has some sort of pointers and but it's after a while you do understand this code. And back down is this is configurable by the program itself. Yeah, you don't have to do not much here. If you're programming bare metal, you have to do everything by yourself here, but I'm programming at the highest level of the STM32 cube. So that means that the program will do some things by itself, and I don't have to read a lot of data sheet or data sheets, yeah, into this. So this is the clock enable voltages, the oscillator from the crystals, D square C. I gave the maximal speed, that's 400 kilohertz. And the addressing bit mode is standard because it's only one. It's only one LED. We have no sensors, else you would have to mess around with the addressing code. So, and this is a GPIOs. In the GPIOs, always I put always in my projects until now. I'll do pull up and pull down. I mean, it depends on the project, but I always pull down in the software, in the microcontroller, and in the hardware outside the microcontroller. So I'll put everything down. Yeah. Yeah. So and that's it. Yeah. I mean that's it. I mean the queue it's complicated. The algorithm is simple and effective. I mean for those who understand, this is a simple code and an effective code. For the ones that don't like to work with RTOS. I mean, yeah, RTOS is a bit more complicated than this. And bare metal, I don't want to even talk about it, yeah. Because, yeah, because you have to go deeper in the function bits of the microcontroller. So I want to show something about here the how did I get there, but I will open another project. I mean, I have a project in FreeRTOS. I will simply do a copy from the main copy because if I open the paste, yes, just doing copy the main because the main is going to be erased after I open this configuration panel. Oops, it's not that. No. After I open the configuration, the main menu is going to be deleted, so everything I wrote in the main is going to be gone. So I just wanted to show you guys how simple it is to program in an STM32 cube. It's real simple. So I'm doing this in the FreeRTOS environment. It's everything here. You can, yeah. The FAT-FS to drives for the USB. Yeah, but I'm doing this in FreeRTOS, but it doesn't matter. It doesn't matter. Yeah. You can even change everything to your program. You have the system core. You have the pins inputs, outputs here. So you give it some sort of graphically. Yeah, you don't need to do it by yourself and read all the data sheet. Yeah, that's what I'm talking about. Yeah, you do it graphically. You need to set the pins on and off. You have the timers here. Yeah, you have the timers and the yeah, PWMs. Perhaps the next project is doing this with a PWM. Yeah, yeah, exactly. So yeah, GPU, exactly. Yeah, everything. And this is all done graphically configuration, and this is going to write some code. This configurator here, the main configurator, where you give your microcontroller serial number, and it holds every configuration that you can put it into. Well, that's it. I'm going to show you all the monkey holds the bits out of the PLC, and I'm going to push the limits until you cannot read the bits and bytes anymore. I mean, you're going to see in the further in this video. So let's see. I'm going to test. I'm going to show the options in the menu and in the PLC online. So you can see I choose in the menu which word I want to access, 1, 2, 3, and in the options in the PLC programming, it's going to change in real time. Yeah, there we go. I've choose 1, and this is the memory from the PLC that I've chosen in the microcontroller. Now I'm going to choose 2 only to show. So it's 1 in the comparer. I'm going to just choose 2. Yeah, and there it is. So I'm going to show now from slow to quick, and only to show which what is the limit. When you develop something, you want to really push into the limit to know exactly to bring it then 2 steps back and say that's the normal function. So I started with a slow time, and I wanted to push that exactly. I'm going to give now here 15 milliseconds between pulses, and this is 15. It's the optimal time. Yeah, I already tested. I done it back and forth and so on so on. I'm going to yeah. I flash it into the microcontroller. Now I'm going to test it with 15 milliseconds between pulses. This is the perfect time, exactly like the first video. Also sending and receiving the optimal time was 15 milliseconds between pulses. So 50 milliseconds is the optimal. So It works great, quick, as you can see. Now, I'm going to test 10 milliseconds between pulses. And I'm going to the flash into the microcontroller. You need to unplug and plug the other way. And there it is. And reads nothing because it's too quick. Pulses are too quick to be. This setup is too quick for the PLC output. So the microcontroller has no problem to read, but the PLC output extrapolates the I mean, the woodpick cannot work cannot work as quick as the microcontroller. Yeah. Why I said woodpick? Because this is an output relay and we can hear it. So that's the limit. Only to show the limitations of this all set. Now I can play a bit more, but I mean it's a menu with three options, three words, extract three words out of the PLC. I mean there's nothing here to be said anymore. Everything else is it's just to show that this is the optimal time, the optimal setup in this case. So I'm going to, yeah, I think I'm going to show a bit yeah. So that was a bit from the woodpick in the slower time, yeah. Uh, yeah, and that's it for this for all this set, all this idea. Perhaps I will make a video with the same PLC and this microcontroller or another one. I will make another perhaps another microcontroller, a quicker one, because this microcontroller has an 80 megahertz stacked. The other one has 100 megahertz stacked. It will be perhaps better, but I don't know. And do it with FreeRTOS. I mean, I need four tasks: one for the menu, one for the inputs, one for the main loop, and the other one for the LED. Um, Perhaps I will make that. Yeah, yeah. But with I have to hack on the high-speed ports from this PLC. Like I said, like I wrote in the beginning, you can do this with Siemens, Mitsubishi, and all the others. Yeah, I mean all the others. And that's it for this video. Yeah, I'm going to end here for this year. Mm, that's all. From ideas this year, I don't will not have any more ideas. Yeah, yeah.
I've been looking for you for 8 months. Whenever I should have had a gun in my right hand, I thought of you. Now I find you in exactly the position that suits me. I had lots of time to learn how to shoot with my left.
When you have to shoot, shoot. Don't talk.